All right. We're going to do this worksheet called Chance Error. So, part A, sum of the dice. Create a box model for the sum of the rolls of a fair six-sided dice. So, in the box, I put the numbers 1, 2, 3, 4, 5, and 6. The sum of the box is going to be 10, 21. So the sum of the box is 21. The average of the box is going to be 21 divided by 6, which is 3.5. Okay. The standard deviation of the box. Can I use the shortcut? No, because I have 6 different tickets in the box. So I go to Stat, clear out my L1, and then I put these numbers in, and I run a one variable statistic, and sigma x says the standard deviation is 1.7. Okay, number 4, calculate the expected value and standard error for 144 rolls. So my expected value is going to be 3.5 times 144, and my standard error is going to be 1.7 times the square root of 144. So 3.5 times 144 is 504. So that is the center of my normal curve, except I'm not very good with writing with this yet. Plus or minus 1.7 times 12, 20.4. All right. So what percentage of the roll of those who roll 144 times will have a sum less than 490? So this is just chapter 5. I draw a line at 490 and I shade to the left. So value, which is 490, minus average, divided by the standard error. So that's negative 14 divided by 20.4 is negative 0.68. So now I shade from negative 5 to negative 0.68. And we get an area of about 25%. All right. So number 6 says, calculate the expected value and standard error for 25 rolls. So I'm going to back up to here. Same average of the box, same standard deviation, but I'm going to times this by 25. And I times this by the square root of 25, which is 5. So 3.5 times 25 is 87.5. So I draw a new normal curve. 87.5 goes in the middle. And 1.7 times 5 is plus or minus 8.5. Am I going too fast? Sorry. Okay. So I times my 3.5 by 25. I times my 1.7 by the square root of 25, which is 5. And I end up with 87.5 plus or minus 8.5. Okay, we good? Number 7, what percent of those who roll 25 times will have a sum exactly equal to 87? So I want just the box that contains 87. What is the left side of the 87 box? 86.5. And what is the right side of the 87 box? 87.5, which happens to be the average. And that's nice because the z-score is 0. So I need to find the z-score for this. And the z-score for that is automatically 0 because it is the average. So to find the z-score of the left side, we do 86.5 minus 87.5 and divide that by 8.5. The numerator will be negative 1 divided by 8.5. And I want to shade norm from negative 0.1176 to 0. So clear the draws. Shade norm. So negative 0.1176 to 0, not 5. Should be the little thin box right there near the average, and I get 4.6%. So the area of this box is 4.6%. Okay. What if I wanted to find from 70 up? Would I need to use edges? Yes. Why do I need to use edges? Because the number of draws is only 25, and anytime it's less than 100, you need to think about using edges. Okay? So when we drew 144 times, we didn't even care about edges. But if it's less than 100, you need to at least consider it. Alright, so 8 is the same, 8 and 9, 10 and 11 are all kind of the same. Can you guys handle those? You just need new standard errors and new expected values. Part B. Same dice, different box. Create a box model for how many even numbers are rolled in a fair 6-sided dice. So what's going to go in that box? 3 1s and 3 0s. Or if you're lazy like me, what box could we also use? 1 0. And you're going to get the same answer either way. But the 1 0 box is a lot easier than the 1 1 1 0 0 0 box. So, toss this thing out. What is the average of a 1 0 box? 0.5. What is the standard deviation of a 1 0 box? 0.5. So if we do 144 rolls, then my expected value will be 72, and my standard error will be 6. 1/2 of the square root of 144. So I draw my normal curve. I put 72 in the middle, plus or minus 6. Do I need to worry about edges? No, because my draws are bigger than 100. What percentage of those who roll 144 times will get less than 72 even numbers? What's that area there? 50%. That was easy. Then you're going to do the same thing with 25 rolls and 400 rolls and so on. And then on the back side, you have a part A and a part B. The only difference is you're rolling an 8-sided dice instead of a 6-sided dice. Okay? All right, get to work.